Here we go. Here we go. So we need to calculate the amount of money in your account if you invest $1,000 for 3 years at 5% interest per year. Let's start with the equation. What do I need to write down first? Raul?
You should probably write down maybe first, probably the initial value. Well,
Not even that. What's the equation that we're working with, Nick?
Instead of writing f of x, can we write y?
You can, but I'm going to write f of x. Okay? Brennicky?
F of 3.
Okay, so, not even that. F of x equals, what's our general equation here? Yeah, Martha.
A
A
times 1 plus 1.
times 1 plus r. Okay, to the x
Where's
power.
that now?
Huh? A,
Oh, x. Oh.
r, and x. In this case, A represents our initial amount. It
No,
is
no, I got it.
$1,000. R is our rate, 0.05. We don't use a percent, we don't use 5%, we use 0.05, we use a decimal. X is going to be 3. So we're going to have f of 3 equals 1,000 times 1.05. I assume you all see where I got the 1.05 from.
yes.
Okay? So third power. You run this through your calculator? Raul, what do you get?
You get $1,157.63.
Very
Okay.
good, Raul. I'm proud of you.
Thanks, Harry.
Good job. Are there any questions? Any questions on this? Nick,
I didn't get that.
what did you get?
Well, when I timed 5 to the third power, it said 1.25e negative 4.
Okay, so you typed it in wrong is what it basically boils down to. And it's not being times to the third power. Remember, put this in your calculator. 1,000
Put 10.
times 1.05 caret 3. Don't forget it's raised to the third power.
Oh, 100.
Make sense? All right.
Forgot the 1.
Forgot the one. No worries. Any other questions?
Wait, why do we have this one?
The 1 represents the initial value. Okay? So the 1 says we're going to hold that $1,000 and add on whatever 5% of that is.
So
We're going to do that 3 times over.
So you always have a 1, like no matter what equation you use, you always use it?
I'm hesitant to say yes because I don't understand your question.
Is there always a way?
Like for everything, like for every function or whatever, is always going to be 1 plus the,
Plus something?
yeah.
You'll see today, no, that's not the case. Okay?
But why is it 1?
Why is it 1? Because it represents the initial value that we started out with. You remember back to the first day of this, we talked about adding these things, 1,000 plus 1,000 times 0.05. That 1 represents that first iteration, that 1,000. If we didn't have that 1, if we got rid of it, we'd have 0.05 to the third power, which is a really tiny number, times 1,000. It would imply that we didn't earn any money, but in fact we lost a ton of money. Brennicky.
If you didn't use the 1, it'd just be like you're not accounting for the money that you already have, just the money that you've gotten.
It'd be just the interest that you've earned. In this case,
Oh, okay.
$157.63. Great.
Oh, so it's kind of adding the
Yeah.
initial value and, okay.
Exactly. Yep. Other questions? All right. Well, this is all well and good. This is all well and good. But here's the thing. This isn't how banks operate. And that's good. This is called simple interest. Simple compounding. Yeah.
So we could use it for like banking later in our life?
Absolutely. And that's where we're going today, is we're going to talk about a method that the banks actually do use and that they're not consistent about. So it's up to you to decide what's the best method to go.
I know it works in banks.
All right? So, this right here is simple compounding. When we're talking about a problem that compounds once per year or once every period, whatever that period may be. It may be 10 weeks, it may be 10 months, but once every period it compounds. So let's look at something that's a little more complex. Let's look at compounding interest.
What's that?
I was
That's
wondering.
where we're going today.
What is compounded money? What is compounded?
Oh, good question. Compounding means earning money and then earning interest off that money that you've already earned interest on. Okay? So what we found is a simple compounding case where we earn interest every year and then that compounds. And we earn interest on the original plus the interest.
So increase,
Yep. Okay? And it gives us these exponential functions. Alright? Well, this is what we're going to talk about today, is compounding interest. Compounding interest. Okay? It's our interest earning interest. It's our interest earning interest. And let me say that again. It's our interest earning interest.
Oh,
Raul.
wouldn't it be a 2 then instead of a 1?
Nope.
Whoops.
Okay. So, what I just said about the simple compounding is that it's once a period, once a year, or once a month. But what if we said it compounds 4 times a year? What if it compounds 4 times a year? So in March, we get interest added to our original principal. Then in June, we get interest added to the interest and the principal again. Do you think compounding interest is more beneficial than just a simple compounding? Or not? Brinicke, you say yes. Why?
Because then you get more money.
Okay, you're compounding on the interest that you've gotten already. So it's advantageous to have some money, or it's advantageous to have more compounding situations.
So you're getting interest on your interest?
Yes. Yes. And that's exactly right. So the equation we use, in general, is this. Could I substitute a for f of x?
You
I
cannot.
could. I could call it something else. This is generally the way you're going to see it written, however. A is your amount after t years.
Oh, so it will always be a 1. Still.
No. That's where we're going to go today.
What is that? Is that a T?
Yep.
Oh.
P is your principal investment.
But is this gonna help you like later in life?
Yep.
Like, let's use a principal investment.
In this case, it would have been $1,000. Okay, it's the amount you originally, yes, your initial value. Okay, it's the amount you first put into the bank. R is your rate of interest. It's your rate of interest. N is the number of times we compound. Number of compounding times. T is our period. 1 year, 1 week, 1 month. Martha.
What do you mean by the number of compounding times?
This will make a little more sense when I give you an example. Okay? So give me 2 seconds and we'll get there. Oops. So let me let everyone catch up. Great question. That's exactly where we're going. We good?
Yeah.
Yep. Couple more seconds.
Period? What does period mean?
A period is like a year or a week.
Wait, is that a plus or a T?
T.
No.
It's time.
And is that a plus sign or T?
That's a plus. My T's are always going to have this little leg thing to them. Pluses are just going to be that.
wait, P says principal what?
Principal investment. So whatever your initial investment is, that's going to be called your principal. Aiden, can you turn the lights? Sorry.
No, I can't see.
My
Can't
God.
Yeah, they're a bunch of babies.
God. We're vampires.
Okay. So, here we go. To date, we've talked about simple interest. Guys? To date, we've talked about simple interest. We've been talking about cases where we compound once a year. I have $1,000, it sits there for a year, and then on the day 366, boom, I get my interest added, and I go for another year. And day 366,
365.
well, I'm going for, is it 365?
Yeah,
It'd be
it's
like-
like-
it'd be 365.
Okay, so it's a year for, okay, yeah, we're going to leap here. So, 365. We compound, we add, we move on. 365, we compound, we add, we move on. 365, we compound, we add, we move on. 366, we compound, we add, we move on. So on and so forth. All right, any questions on that? On what simple interest is? So if we're talking about compounding interest, to Martha's question, we're saying, rather than just waiting until 365 days have passed, let's compound every 3 months. Let's compound quarterly. So every 3 months, we're going to compound X percent. But it's not X percent. You are usually given that percentage as a function of a year. So it's 5% per year compounded quarterly. 3% per year compounded monthly. 3% per year compounded semi-annually. You'll see those kinds of statements. But you're not going to see compounded once a year. Yeah, Raul?
When you put it in the equation, when it's the power n t, would you combine n and t, like say n was 4 and t was 1, would it be 5 to the 5th power, or would you multiply those?
This is implied multiplication.
Okay.
When it's just adjacent to each other, it's implied multiplication.
What is that?
Huh?
What is that?
Means we multiply them. So if we compound 4 times in 3 years, we compound it 12 times.
Oh, so you just put it to the 12th power.
Exactly.
Okay.
So let's go on to an example. And see if we can kind of get an idea of what's going on. Can I erase this?
You can.
Sorry. Okay. Here we go. So here's what you'll see sometimes. So find the amount
Find the amount of
What does that say? Does that make, Mr. Morgan, that doesn't make sense. Find the amount
A of a $1,000 investment with 5% interest compounded annually after 3 years. This is our warm-up. This is our warm-up.
Except you just add
Wait,
it.
wouldn't that be once a
But it's once a year. Okay? What was our warm-up? Compounded annually?
Oh,
It's our warm-up.
Excuse me, Mr. Morgan.
Okay? It's our warm-up. And the reason I'm putting this up here is I want to draw a distinction. We're going to look at the same problem. We're going to look at the same problem.
We're doing a chart.
I'm going to hold it off over here, and I'm going to see if you guys pick up on this. Yeah, Martha.
I thought you said it would be in every year.
this is just.
This is just the warm-up. I'm just trying to drive home a point. Okay?
Do you want us to write down the chart?
We can hold on the chart and just look here.
Okay.
So, we compound once. What did we get out?
$1,157.67.
115763. Okay, that was our warm-up. Now we're going to change it. Instead of compounding annually, we're going to compound semi-annually.
Semi means half.
Okay, so instead, we're going to take the exact same numbers. We're going to take the exact same numbers. $1,000 initial investment, 5% interest, over the course of 3 years, but instead of compounding once a year, we're going to compound how much?
Twice a year.
Twice. We're going to compound twice. Does anyone not understand what I just said? Raul?
How does that fit into the equation?
Well, great. It's a good question. If you just need to write down the basic information here, what I would say is rather than writing this all, just write P equals 1,000, R equals 0.05, n equals 2, we'll get to there in a second, t equals 3. Okay? All of that can be succinctly written like that.
Wait, what does that mean?
It means shorthand.
That actually.
Okay,
What does that mean?
n equals 2. Alright. Now, what I just said is, when we move from simple interest, the equation we were talking about all last week, to compounding interest, what we're talking about today, we got to shift our equation a little bit. So we're going to look at a equals p1 plus r over n to the nt. Okay? So we've got compounding interest. Well, reading this, what was our initial value again? 1,000. What was our r? 5%, or as a decimal?